Hi, welcome back. In this video, we're going to talk about similar polygons. If you are not comfortable with solving a proportion, I strongly recommend you to go back and watch that 7.1 video, Ratios and Proportions, because proportion is going to be very, very important moving forward for the rest of the unit. If you know how to solve a proportion, then all we're going to be focusing on is how to set it up, given different scenarios. For this scenario, we're going to be talking about similar polygons. And a polygon is really just any shape that is an enclosed figure with straight lines. Okay, so here we have a four-sided polygon, and we have two of them. I know from here that these two polygons are similar. This is the similar symbol that we use for similarity. We have used a congruence symbol before, and now we're talking about similarity. So the difference here is congruence means same size, same shape. Here, same shape, different size. Okay, so let's talk about what makes these two things proportional and what these symbols are about. Okay, let's see. So when two polygons are similar, what it means is that the corresponding sides are proportional. If I go ahead and look at this side corresponds with this side because we're going from one arch to two arches. One arch to two arches. Also, AB is the first two letters of this of the similar symbol statement that we have, and WX are also the first two letters. So I know that they correspond with each other because of the angles, the arches, or because the length or the order in which the letters are written. What similarity means is this: the ratio between the sides, 15 is to 5. It's going to be the same, as the ratio of 18 to 6. If you think about it, 15 divided by 5 is 3, 18 divided by 6 is 3, 12 divided by 4 is also 3, and lastly, 21 divided by 7 is also 3. For two polygons to be similar, we have to have congruent angles, and that's what this represents, that these angles are the same, right? And the corresponding sides, all of these sides, have to have the same proportion, and they're all equal to each other. If that happens, the picture's either going to increase or decrease in size at the same ratio. That's why we have equivalent ratios, hence the definition of a proportion. So, if polygons are similar to each other, they are going to be proportional in size. And that's what's going to help us find either missing pieces or something that we're interested in finding. If polygons are similar, they are proportional. Let's check out some examples. Now here, we first want to identify the similarity statement. NPQR is similar to UVST. Now there's no symbols in here, so we can use the fact that the N is the first letter and U is the first letter. So those two are corresponding with each other. So that means that N corresponds with U. Those are congruent. P corresponds with V because those are the second letters. Q corresponds with S. And then this last angle that I'll leave blank because it's the last letter. R corresponds with T, so this angle should be congruent to this angle. Okay? Now that I know what angles are corresponding with which angles, I can also figure out which sides corresponds with each side. Notice how the first two letters correspond with the first two letters. NP corresponds with UV. So I can say the ratio of NP is to UV. That's this piece. NP and UV. The next angle or the next side, I can also even use the symbols. I can look at how I'm going from one arch to no arches. Here I can go from one arch to no arches. So NR corresponds with UT. I have this side corresponding with this side. I can now go to the other piece, RQ, no arches to 3 arches. No arches to 3 arches. So RQ corresponds with TS. And then lastly, we have the diagonal. That might be easier to identify, but if you can't, remember that we have 2 arches going to 3 arches, 2 arches going to 3 arches. So PQ is corresponding with VS. And the reason why I'm writing them as ratios and as equality sum statements is because the ratios of all of these corresponding sides will always be equal. All right, the next topic I want to talk about is how to find the scale factor, or what this scale factor is. A scale factor can be expressed as a fraction or as an equation that looks like this. The formula for scale factor is the new, so part scale factor I can't seem to write for some reason. It's not reading my. Okay, so if we have the new image divided by the original image, or the old image if you prefer to call it that way. And what that means is this. We want to figure out how this picture is changing. How is this increasing or decreasing from here to here? What scale factor, or at what size, or at what magnitude is, or at what ratio is it going to decrease or increase in size? So when you're looking at a statement, here it's telling you it's going from ABC to XYZ. It's going from the bigger one to the small one. So the small one is your new, it's going to be considered your new polygon. And the one that you start with is considered the old one. So all you have to do is find the corresponding sides. The new one is 3, and that corresponds with 6. Therefore, my ratio is 3 over 6, or 1/2, if you simplify it. What does this mean? It means that if I take the original image, or the old image, and I multiply everything, all 3 sides, by the scale factor of 1/2, I'm going to get the sides of the third image, or the second image. So 6 times half is 3. If this side over here was 10, you divide it by half, you would get 5. If this piece was 4, multiply it by half, you get 2. So you can use the scale factor to predict the measurements of the other shape, the new shape, based on a ratio that we created. You divide the new image divided by the corresponding old side of it. And that ratio becomes the scale factor. So now we're going to calculate the scale factor in the other direction. Now we're going to go from XYZ, from this triangle, to this one. Now the picture is going to increase in size. So you start with the new one divided by the old one. And that's going to be 6 over 3. Or 2 over 1. And intuitively, hopefully this makes sense, right? What do I need to multiply this to make it look like this? Multiply it times 2. And it increases. Again, if this side is 4, you double it and you get 8. If this side is 5, you double it and you get 10. So the scale factor is used as a way to compare the new image to the old image. Whatever image you have, you can enlarge it or reduce it in size by multiplying it by a scale factor. If the scale factor is bigger than 1, it's going to increase. If the scale factor is smaller than 1, it's going to go smaller. It's going to reduce in size. Okay, so here lastly, we know that these two polygons are similar because notice how the corresponding angles have congruence. So when all of the angles are congruent in polygons, I can then identify the parts that correspond with each other. Notice how here I go from 1 arch to 2 arches. So this corresponds with LM, 1 arch to 2 arches. So the ratio of 14 to x plus 9, the ratio of 14 to x plus 9 is going to have the same ratio as 10 is to x plus 6. Because these two figures are proportional, they're similar. And because they're similar, they're proportional. So you can create a proportion with the sides that correspond. So as long as you know what sides corresponds with which sides, based on the angles or the measurements or the letters, you can then make a proportion and solve for x. How do we solve for a proportion? Again, if you don't know how to solve a proportion, go check out my 7.1 ratios and proportions video. I do 3 examples in there on how to solve proportions. But proportions, you cross multiply. So we're going to take this bottom stuff, we're going to cross multiply with the 14. So you have 14 times x plus 6. And that's going to equal the bottom side, cross multiply with the top. 10 times x plus 9. Okay, this is an algebra 1 problem. At this point, you do distributive property. 14 goes into this one. 14 times x is 14x. 14 times 6 is 84. On the other side, 10 times x is 10x. And 10 times 9 is 90. And then you just combine like terms, right? You want to move the x's to the same side. So I'm going to subtract the 10x to move it to the left. We're left with 4x plus 84 equals 90. You want to move the 84 to the other side. So I'm going to pick up this problem over here on the side just to continue solving it. We have 4x plus 84 equals 90. So move the 84 to the other side by subtracting. Subtract 84 on both sides. So 4x equals 6. To leave x by itself, since you're multiplying times 4, the opposite is to divide by 4. X equals 6 over 4. Or, if you simplify it, they're both divisible by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. And we want to leave this as fractions because we're dealing with ratios instead of decimals that you have to round and stuff. All right? So, let me know if this helped by clicking the like button. And if you haven't subscribed, go ahead and do so already. All right, guys, hope this has helped. And as always, we'll calculate later.